So now we go through for the example here. So we have the example, it is given by the f, we have the functions over here. It's given by the function here. And next we're going to do the numerical approximation to find the f double prime 2.3. So mean that we want to get the values for the second order derivative using 3-point center difference formulas, 4-point backwards, 4-point forwards, and 5-point center difference formulas. And it's given by here using the step size your h equals to 0.1, and then we're going to find the absolute errors. So how much the difference from the numerical approximation to the exact solution. So this is what we're going to do for the next after you get all the answer done. And based on the answer, the errors that we have, we want to make the decision which one is the best approximations. We're going to choose, we're going to select which one is the best. So for the first one, we're going for the 3-point center difference formulas. And this is the 3-point center difference formula here. And we have the fx, we have the fx plus h and fx minus h. So where is the value we need to substitute actually? So because our x here is 2.3, that means we're going to step forwards. This is the 2.4, and this is our x plus h. And the same thing for 2.2, actually it's just our h, x minus h. And how to get this value actually? So actually it's a value that all the x here, the x variables here, and this x variable is substituted to the functions, you will get answer. And be careful because this is a sin x, so mean it is a trigonometry function, and make sure your calculator are in the ready modes, otherwise you won't get the answer like this. So assume that you already get the answer. So what you need to do is you're going to substitute each of them one by one. So mean that this is a 2.2, f2.2 you're going to substitute over here, and 2.3 you're going to substitute over here, and then the next one 2.4 you're going to substitute here. And since the h is given by 0.1, and this is what you put in here, and then next you just go for the simplification and you get answer. So you will do the same thing for the rest. For the 4-point backwards difference formula, first of all we take a look what is the formulas for the 4-point forward difference. Sorry, it's a backward formulas. It's a backward 4-point backward, meaning that you're stepping back, meaning that you're starting from 2.2, you're stepping back, minus h, 2.3 minus h, 2.2 minus 0.1, you get a 2.1, minus h, again you get a 2. And this is 1, 2, 3, 4 points, so that's why this is 4 points. And this is what is stepping back. And this value is 2.3, actually this is your fx. And this is the minus h, the f minus h, f minus 2h, f minus 3h. So next, you just fill in what is the corresponding values here. This is your x, and minus h, and minus 2h, minus 3h. And this is your h value. And next you just simplify, you get answer. So this is the same thing, exactly the same thing for the forwards. It's just a different, you are starting from 2.3 plus h, you get 2.4, and then next you go for the 2.5, and then next you go for the 2.6. It's just a plus h, 0.1 increment. So, and yes, this is the formulas. And next you just fill in the values, the corresponding values according to the formula, and then you just do for the simplification, you will get answer. So the last one, exactly the same thing. You have the 5-point, of course the 5-point formula is a bit complicated and longer, so you need some time. So meaning the 5-point is starting from plus 2h, actually this is your h starting here, so you have the plus h, plus 2h, as well as minus 2h and minus 2h, sorry, plus h and minus 2h. So this is the initial reference here. You have the h, sorry, you have the x here, the x plus h, meaning it's 2.4, and then plus 0.1 is a 2h, 2.5. The same thing, you go backward, minus h, minus 2h. So this is what you have here, and this is your function value, this is the function values. So later you just substitute the function value into the formulas. So like this one, Of course, the fx here is just a reference because you want to get the f double prime 2.3. You just substitute inside. So this is what you have here next. And of course, once you have these values, you're going to substitute each of them. This one, you're going to replace in here, and this one is come from these values. And f2.3, of course, come from the 2.3 formulas, and this one as well. And then the last one, yes. And then you just simplify. You will get the answer. Since we already have the 5 answer, the 5 values of the approximation, we want to know which method is the best approximations. To know the best approximation, we need the exact value or the exact solutions for the derivative f x equals to 2.3. So this is the function that we have here. So we're going to differentiate twice. So differentiate the first one, we get the first derivative. Differentiate again, we get the second derivative. So once we have these second derivatives, so we're going to substitute all the x variables here with 2.3. So this is what the values, 2.3. The f double prime 2.3 is minus 2.11077. So this is what the table that I tried to summarize, and this is the values that we calculate based on our numerical formulas. The numerical difference 5 points, 5 points, 4 point, and 3 point formulas. And this is the exact value that we have from the previous one. And just what I did here, I just do the minus, the exact minus with the numerical solution, and this is what I get. This one, the same thing I minus. And lastly, I find out the 5 point difference formula is the best one, since the error is smallest. Yes, of course, this is smaller because this is almost 0.